Hey folks, welcome back. In this video we're going to go over question 1 from the 2019 SQA Advanced Higher Physics exam paper. So let's get started. Question 1 says a spacecraft accelerates from rest at time t equals 0. The velocity v of the spacecraft at time t is given by the relationship v equals 4.2 t squared plus 1.6 t, where v is measured in meters per second and t is measured in seconds. It then says using calculus methods for part A, determine the time at which the acceleration of the spacecraft is 24 meters per second squared. And you can see there's 3 marks available for this. Well, because we've got an expression for velocity and we want to determine the time at a given acceleration, that means we first need an expression for acceleration. So let's differentiate the velocity expression v with respect to time t. So we can rewrite A is equal to dv by dt, which remember is just an equation on your relationship sheet, and we can write that that is the same as d by dt of v, which is 4.2 t squared plus 1.6 t. So remember, to differentiate we want to bring the power down and multiply it by the number in front and then take 1 away from the power. So bring the 2 down and multiplying it by 4.2 and then taking 1 away from the power, we'll just leave t for this part, so we get 8.4t, and then if we take the power 1 down and multiply it by 1.6, that just stays as 1.6, and taking 1 away from the power here will give us t to the 0, which is just the same as the number 1. So that's 1.6 times 1, which just gives us 1.6. And now that we've got an expression for the acceleration, we want to substitute in our acceleration to get our time value. So we now want to substitute the acceleration value, so we have 24 is equal to 8.4t plus 1.6, taking 1.6 away from both sides and then dividing both sides by 8.4 to get t on its own will give us an answer of t equals 2.7 seconds. Part B says to determine the distance travelled by the spacecraft in this time, and again we've got 3 marks available. Well, remember we've got an expression for velocity v in the question, and if we want to determine the distance or displacement s, then we're going to need to integrate rather than differentiate. So if we integrate the velocity v with respect to time t, we can rewrite v as being equal to ds by dt, which is another equation on your relationship sheet, and we can say that's equal to 4.2 t squared plus 1.6 t. We can then sort of ignore the v and integrate both of these. So we have the integral of ds by dt is equal to the integral of 4.2 t squared plus 1.6 t dt, where I've just used brackets here to show we're integrating both parts of this expression. So integrating velocity with respect to time will give us displacement s, and then remember to integrate we want to raise the power by 1 and divide by the new power. So we have 4.2 t cubed over 3 plus 1.6 t squared over 2 plus c, where c is our constant. And then we could simplify these fractions to get s equals 1.4 t cubed plus 0.8 t squared plus c. Now to find out what the constant c is, we need to consider the initial conditions. And remember that's just what happens at time t equals 0. So at time t equals 0, we can say that the spacecraft hasn't travelled any distance, so its displacement s is equal to 0, and therefore if we substitute in t equals 0 into here and s equals 0, then we get c equals 0. So we can rewrite s as s equals 1.4 t cubed plus 0.8 t squared. Now we're told in part B in this time, so we want to use our answer from part A for the time and substitute that in to find what s is. So we can say lastly substitute the time value calculated earlier, so we have s equals 1.4 times 2.7 cubed plus 0.8 times 2.7 squared, and if you put that into your calculator you should get an answer of s equals 33 meters. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.